Hi friends, today I will tell you about the frame of reference. The frame of reference means the coordinate axis associated to an observer. Now what are coordinate axes? Three mutually perpendicular directions represented by x, y and z axis will form coordinate axis. Now x axis, y axis and z axis are always taken as right-handed triad. Means if thumb represents x-axis, then first finger of right hand will represent y-axis and the middle finger will represent z-axis, provided all three are mutually perpendicular to each other. Now the frame of reference can be of two types, one inertial frame of reference and another non-inertial frames of reference. Inertial frames of reference are those frames of reference in which Newton's laws of motion hold true. That is, the frames of reference which are either at rest or are moving with uniform speed. While other types of frame of reference, non-inertial frames of reference, will be those frames of reference in which Newton's laws of motion, that is the laws of inertia, will not be obeyed. Such frames of reference will be accelerating frames of reference. It means the observer to which coordinate axes are associated will be accelerating to form a non-inertial frame of reference. Now, if observer in non-inertial frame of reference is accelerating, then to that observer an object at rest will appear to be accelerating in opposite direction. Because of that, an object which is not having any force acting on it will seem to be having a force acting on it because of the acceleration of that object, as acceleration is always produced by a force. So it means in a non-inertial frame of reference, if an object is kept at rest, that will also seem to be having a force acting on it. That's why the laws of motion will not be obeyed in non-inertial frames of reference. Now the relativity in motion. Relativity means comparability. If we are comparing the heights of two objects, then we may say one is smaller and another is larger. So it means heights can be less or more. In the same way, if I am facing towards the camera and one door is towards left of my side, then to a person who is facing me, the same door will appear to be at right. It means the position of door will be relative. As position is relative, the velocity will be relative. If velocity is relative, then acceleration will be relative. It means motion is also relative. That depends not only on the position of observer, also upon its state. That is whether the observer is at rest or the observer is moving. Now, to deal with relativity in motion, we have two theories. One is special theory of relativity and another is general theory of relativity. Special theory of relativity deals with the motion in inertial frames of reference. It means if observer and object whose motion is to be studied both are in inertial frames of reference, then the theory which will deal the motion of object will be special theory of relativity. But if the observer observing the body is accelerating, it means the object is placed in non-inertial frame of reference, then the theory of relativity will be called general theory of relativity. Now, if there are two observers in inertial or non-inertial frames and both the observers are viewing the same object, then the coordinates of the object seen by two observers will be different because of relativity. If coordinates will be different, then the equations that will relate the coordinates of an object by one observer with the coordinates of same object for the another observer will be called transformation equations. And these transformation equations are of two types, one called Galilean transformation equation and another Lorentz transformation equation. Difference between these two transformation equations depends upon the fact that in Galilean transformation equations relativity in time is not taken into account, while later on in further studies it was found that the time is also relative for two different observers, and if relativity in time is also taken into account, then the transformation equations are called Lorentz transformation equations. In next video I will tell you about the derivation of Galilean and Lorentz transformation equations.